In this lecture, we will take a look at identity and access management in AWS. In the previous demo, we saw how to set up an AWS account. To sign up, we used an email address and a password. After completing the sign-up process, we can now log into the AWS Management Console using the same credentials. This email address that was used to sign up to the AWS account is also known as the root account, and it has complete administrative privileges. You can manage any service within AWS using the root account, but this is not the recommended approach. This user account can be compared to the root user in Linux and admin user in Windows, which have complete administrative privileges to carry out any task in the operating system. And just like the root or admin user, you should not rely on the root account as your daily driver to operate your AWS account. When your AWS account is just set up, this is the only account you can use to sign into the management console. However, using the root account, we can create new users and assign them appropriate privileges. That should be the only purpose of using the root account. Once these users have been created, lock away the root account credentials securely and do not use it unless it's absolutely necessary. To start off, let us create a few new users called Lucy, Max, Abdul, and Lee. When we create users in AWS, there are two types of access that we can configure: access to the management console and programmatic access. To access the management console, a user should have a valid username and a password. The programmatic access is used to interact programmatically by using command line interfaces such as the terminal on Linux and Mac or PowerShell in Windows. To do this, we create an access key ID and a secret access key, which need to be configured on the CLI before we can start making use of the terminal to connect to AWS. The programmatic access keys cannot be used to log into the management console. We will see how to use these in a demonstration video that follows the lecture. Now, let us see how to assign permissions to these users. As a standard, when a user is just created, AWS assigns least privilege permission to the user. What a user can or cannot do in AWS is decided by the permissions that are defined within an IAM policy. For example, let us assume that Lucy is the technical lead for a project that will be deployed in AWS, which is the reason why the AWS account was created. She needs to have admin access to all services and resources in AWS. To do this, we can add an IAM policy called Administrator Access to her user account. This policy, along with several others, are managed by AWS and are available to use when creating a user. An IAM policy is defined in a JSON format. If we inspect the JSON document of this policy from the AWS console, we can see that it's a simple JSON document that defines the permissions granted by the policy. Under the policy statement, we can see the resources that are applicable to the policy, the action that can be carried out on those resources, and the effect of the policy. In this example, the resource and action have a value of star, which means all resources in AWS and all actions. And the effect field has a value of allow, which effectively means allow all actions on all resources in AWS, which is why this policy is known as the administrative policy. Once this policy is attached to Lucy's user account, she has complete access to all the resources in the AWS account. As mentioned previously, the Administrator Access policy is an AWS managed policy. There are several of these provided by AWS that are designed to provide permissions for many common use cases. One such use case is assigning by job function. As we just saw, Lucy, being the technical lead and the owner of the account, has been granted admin access by attaching the AWS managed Administrator Access policy to her user. Here are some more AWS managed policies that are designed for specific job functions, such as a billing policy that will allow users to view billing information, set up and authorize payments. The database administrator policy that allows users to set up, configure and maintain databases such as DynamoDB, RDS, etc. in AWS. The network administrator policy grants permissions to the user to set up and maintain AWS network resources. For the complete list of policies categorized by job functions, refer the reference document that follows this lecture. The other users of this team, Max, Abdul, and Lee, are developers who need access to AWS EC2 and the S3 service to develop their application. To do this, we can attach two managed policies to each user like this. Better yet, since Max, Abdul, and Lee are part of the same team and have the same permission, we can add them to a group called developer. An IAM group is a collection of users, and this allows us to specify permissions to multiple users at once. This way, we can directly attach the policies to the group rather than having to assign them to individual users. If we want additional permission for any user in a group, we can also attach specific policies to an individual user in the group. Once permission has been attached to the group, the users part of the developer group have complete access to EC2 and S3 service in AWS. The access provided so far has been for humans, people who either want to carry out tasks using the management console or programmatically by making use of the access key ID and the secret access keys. Until now, we have seen how to create users, groups, and attach policies to them in AWS. But what about other services? Say an EC2 instance wants to read from and write data to an S3 bucket. Would that work out of the box? The answer is no. Just like regular users, resources in AWS also do not have any permission to interact with other services by default. They need to be granted access specifically. However, unlike regular users, we cannot attach an IAM policy to a service directly. Instead, in order to allow an EC2 instance to be able to interact with S3 buckets, we have to create a role. An IAM role allows us to securely grant access to an AWS service to act on other AWS services in the account. In this example, we need to create a role. Let's call it S3 access role to be applied on the EC2 service. To the role, we can attach the same IAM policy called Amazon S3 full access that we used for the developer group. Once this role is attached to an EC2 instance created in the account, that instance should have complete access to the S3 service. Note that there are other ways to give services such as EC2 access to other resources. One example is configuring programmatic access. This is, however, insecure, but we will see how this is done in the coming lecture when we learn how to programmatically access AWS using secret access keys. Finally, IAM roles are not restricted to just providing access from one service to another service in AWS. Other uses of IAM roles include providing access to an IAM user belonging to another AWS account, providing access to applications to interact with services in AWS, and providing access to users managed outside AWS. For example, access to users of an organization that uses Active Directory. Besides AWS managed policies, we can also create a custom policy of our own. This can be done from the AWS console like this. For example, if we want to create an AWS policy that would grant permissions for a user to create and delete tags on an EC2 instance, we can do it this way. Here, we have the JSON document, which is similar to the administrator access policy, but in the actions, we have specified permissions to create and delete tags for EC2 instead of a star, which is all actions. Once created, the policy will be available to use within the AWS account. In this demo, we will get introduced to the IAM service using the AWS Management Console. We will create users, group, attach policies, create a custom IAM policy, and finally create an IAM role. To go to the IAM service, we can use the Services tab on the top left and then navigate to the group called Security and Compliance. The IAM service should be the very first service listed under this group. Alternatively, we can also search for the IAM service from the service search bar in the dashboard. You will also notice that when we are working with IAM, the region is set to global, And this is because, unlike other AWS services, IAM is independent of the region. Once we create IAM objects, such as a user or a group, it will be available in all regions in the account. Alright, so we are now in the IAM dashboard. Since we just created this account, there are no users or groups created at this point. Remember, right now we have logged into the console using the root account. First, let's create an IAM user called Lucy. To do this, click on Users under the Account Management. Let's provide Lucy as the username. Now, we have an option to provide two types of access for this user. The first one is programmatic access, which creates an access key and a secret access key. This allows the user to access AWS services programmatically, such as making use of the AWS CLI. The other is access to the management console with a username and a password. Neither of these methods are an alternative for each other. You need management access to log into the AWS management console, and you need the access key ID and the secret access key to be able to access AWS programmatically. Let's also provide a custom password and allow password to be reset by the user. With this enabled, users will be automatically attached to a IAM policy that will allow them to reset their own password. When ready, click on Next Permissions. We're not going to add any permission at this moment, so click on Next. We now have an opportunity to add tags for this user, but let's move forward and click on Next. We can now review the details that we entered and finally click on Create User. Once the user has been created, we get the option to download the access key and the secret access key for this user. This is the only time where the secret access key is displayed with an option to download. Once we move past this stage, we cannot see the secret access key again, and we will have to create a new one should we still need to access AWS programmatically. So click on the download button to save the key in a CSV file. As you can see, a user called Lucy has now been created. But this user is not part of an IAM group yet. Let's click on the user. Under the Permissions tab, we can see that the policy called IAM user change password is automatically attached to this user. To inspect what this policy does, we can click on it and check out the JSON document. Let us now attach another policy to this user. Since Lucy is the team lead and needs unrestricted access to every service in this account, let's attach the administrator access policy to this user. So we select this policy and click Next. Review the information provided and click on Add Permissions. Lucy now has two policies attached to her IAM user account. The administrator access policy is perhaps the simplest JSON document. It allows all actions for every resource in the account as denoted by the star. Now let's create a few more users. Using the same process as before, let's create another user called Abdul. But this time, let's add him to a group. Since we do not have a group right now, click on the Create Group button. Let's call the group Project Sapphire Users, and to this group, let's attach an Amazon EC2 full access policy. Click on Next, and let's add a tag this time with the key of name and value of Project Sapphire Users. As before, once the user has been created, we can download the access keys in a CSV file. Let's now add another user called Lee. And this time, let's add him to the existing group called Project Sapphire Users. Both Abdul and Lee are now part of this IAM group and now have full EC2 access. Let's add another policy to this group which grants full access to the S3 service. Next, let's take a look at IAM policies. As we saw in the previous lecture, AWS provides hundreds of managed IAM policies by default, such as the Amazon EC2 full access and the Amazon S3 full access policies that we just used. There are also policies for specific job functions, such as the administrator access and the billing policy. Let's now create an EC2 read-only custom policy. To do this, click on the Create Policy button on the top left. Next, select a service the policy is applicable for. In this example, let's select EC2 as the service. Next, choose the actions permitted. We want this policy to only allow read and list actions. We can also select which resources this policy can be applied on, such as a specific EC2 instance in the account. But for this demo, let's click on All Resources. Now click on Review and provide a name for this policy. Let's call it EC2-list-read. The policy will now be available in the policy list. We can review the JSON document and see that it allows all actions of list and read on all EC2 resources. This policy can now be attached to users, groups, or roles. Similarly, let's create another policy that allows all read and list actions for S3 service. Let's call it the S3 read-only policy. Once created, a quick inspection of the JSON document shows that this policy allows all read and list actions on all S3 resources. Let's now move on to roles. In the previous lecture, we saw that roles can be used for a number of different use cases. We can use them to allow access to users from a different AWS account. We can also grant permissions to services to access other services within the same AWS account. Let's create a role for this use case now. Click on Roles and click on the Create Role button. First, we need to select the type of the trusted entity. This could be a service, or another AWS account, or the organization's corporate directory, for example. We want this role to grant EC2 instances read-only access to the S3 service. So let's select AWS Service as the trusted entity. And within this, select EC2 as the service. Click on Next, and now we can attach a policy to this role. Let's attach the custom S3 read-only policy that we just created. Let's also add an appropriate tag. Here we are providing a value of S3 read-only role for EC2 instances. Click on Next and review the options that we provided. Let's call the role S3 read-only role. And optionally, let's also update the description. When ready, click on the Create Role button. The role is now available for use and can be attached to an EC2 instance. That's it for this demo. In the next lecture, we will see how to use Terraform to work with IAM service.